Good evening. Today we'll be talking about the power rule. The power rule is another technique that you can use to find the derivative of functions. It's kind of like the chain rule in my opinion, but that is just my opinion. 3 disclaimers. 1, I cannot spell, but I will try. 2, I cannot really write straight, but I will try. And 3, my 1s look like this, and my 7s look like that. Not this and this, not that and this or that. These two. So you'll see probably a question with that in it. If it triggers you, I'm sorry. But I mean, that's just how I write it. Blame my teachers, not me. Hashtag not my problem. Alright, so with that in mind, let's go ahead and get into the power rule. All of these notes that I go over in the video will actually be in the comment section as a link to a PDF file. So if you want to know where I'm getting it from, or if you want to refer to my notes, it will be there for you to look at it. So let's say we have a given function p of x that is equal to x raised to some number. Let's define our variables here. So p of x, we'll just call that the function that we will use the power rule on. We will call x our unknown variable or function. For power rule, it's an unknown variable. If it was an entire unknown function, then it would be chain rule. And n will just be any given number. So any given number n. So with that in mind, the derivative of p with respect to x will be equal to n times x raised to the n minus 1. If you want me to write another notation, we could say the derivative of p with respect to x is equal to the derivative of x raised to the power of n over, with respect to x, and that's also equal to, you guessed it, n times x to the n minus 1. And then you could do operator notation if you wanted to. Let's look at some forms. So let's say we have y is equal to x squared is 1. We have y is equal to 2x times the natural log of x as another one. We have y is equal to 2x over e to the x. And we have y is equal to 1 over the cosine of theta. Well, this one is a power rule. This one is a quotient rule. This one is a reciprocal rule. And this one is a product rule. In case you're wondering what it would look like in comparison with other forms. And I've actually made videos on all 3 of these, so you can go watch those videos if you're wondering what you would do to actually solve those. Since I've already made videos on that, I'm not going to go over that in this video. This video will be strictly power rule. With that in mind, we can go ahead and get started with our first question. So question number 1, we have y is equal to x to the 7th. Let's write down our definition we had. We had y was equal to x raised to the nth power when n is any given number. So if we compare both of these side by side, we know that n is 7. And we know that the derivative of y is equal to n times x raised to the n minus 1. We can just go ahead and apply that over here. So we can say y prime is equal to, we know our n is 7, so 7 times x raised to the 7 minus 1 power. We can rewrite that, and we can say that y prime is equal to 7 times x raised to the 6th power, And because there's no negative inside the parentheses, I can go ahead and drop that. And I can say our final answer, y prime, is equal to 7 times x to the 6th power. And that is our answer for question number 1. I'm going to leave that there, and I'm going to erase off this part, and I'm going to move on to question number 2. For question number 2, we have y is equal to 3 times x to the 5th. Let's write what we had before. Y is equal to x raised to some number n. Well, we know n is 5. We don't exactly know what to do with the 3. So let's just keep the 3 on the outside when we take the derivative. We know the derivative of y is equal to n times x raised to the n minus 1 power. So the derivative of y will be equal to 3, keep that outside, parentheses, n is 5, 5 times x raised to the 5 minus 1 power. So y prime will be equal to 3, keep that out, 5 times x to the 4th power, and then we can drop off all of our parentheses, and we would have our final answer, which is y prime is equal to 15 times x to the 4th power. And that is our answer for question number 2. I could maybe squeeze 3 in there, but beauty of a whiteboard, we'll just give ourselves more space to work with. So we can move on to question number 3. Question number 3 is y is equal to 2 plus 5x to the 9th. So this is a pretty good opportunity here. 2 is a number, and we like to call those numbers in math constants. And we know that the derivative of a constant is 0. And if I wanted to explain that in the best way possible, we'd have to, this is really its own separate video, but we'd have to talk about the definition of the derivative. So to go over it briefly, we would say the definition of the derivative would be something along the lines of as h approaches 0, we'd have f of x plus h minus f of x over h. Something along those lines. This would be what we would call the definition of the derivative. So it looks a lot like a slope formula if you think about it, because we have slope is y2 minus y1 over x2 minus x1. Same type of concept. So in order to have a derivative, you need to have a function that can produce a number. So if I have a number line, and I say, well, find the derivative of y equals x, well, we know this has a positive slope, so it'd be a positive number. So we could just say the derivative with respect to x is just 1. Well, if I had a point, and I said find the derivative of this point, there's nothing you can, it's just a point. There's no change of anything. There's no change, there's no with respect to another function. This isn't even a function, it's just a number. So because there's literally nothing you can do with it, using the definition of a derivative, it would actually be 0. Because there's no change, there's no function, there's no slope. There's literally nothing you can do. You can't use as it approaches 0 or as it approaches the number, because it is just the number. It doesn't approach anything. So that's why the derivative of a constant is 0. That's really its own video, but if you guys want me to, just let me know in the comments and I'll go over that one later. So with that in mind, we can use the same thing we used before. So we can say y is equal to x to the n. That means that in this example, n is 9. And we'll just do what we did before. So the derivative of y is equal to 0 plus, we're going to keep that 5 on the outside for right now, 5 times, bring down the 9, I'll write this here. Y prime is equal to n times x raised to the n minus 1. Bring down the 9 times x raised to the 9 minus 1. Which means the y prime will be equal to 5 times 9 times x to the 8th. Since this is positive, I can go ahead and drop those parentheses. So I can say y prime is equal to 5 times 4. 5 times 9 is 45. Times x raised to the 8th power. And this is our answer for question 3. So product rule is the type of thing that's actually relatively straightforward once you get the habit and the hang of the process. At least in my opinion. I think it's a little bit more straightforward than power. Well, product rule is a little bit longer. But power rule is a little bit more straightforward than product rule. It's usually a little bit shorter too. So we can move on to question number 4. So for question number 4, we have y is equal to 2x plus 2x squared. So for this power rule, we actually have to do it twice. So we're going to do it once for the 2x, and we're going to do it again for the 2x squared. Let's go ahead and do it for the 2x first. We'll write off to the side here what we know for our power rule, our definition of the power rule. We'll just keep that there as a reference. So for the first one, we say the first derivative of y is equal to the derivative of 2x. Well, it's 2x to the first power, so we'll keep the 2 out. And then we'll just say it's 1 times x raised to the 1 minus 1 power, and that's the derivative of the first one. Then for the second one, we will say that it's keep the 2 out, and then it would be 2 times x raised to the 2 minus 1 power. And then we can just simplify it down, so we can say that y prime is equal to 2 times 1 times x to the 0th power plus 2 times 2 times x to the first power. Anything to the 0th power is 1, so y prime will be equal to 2 times 1 plus 2 times 2 times x, which means that our final answer, y prime will be equal to 2 plus 4x. And this is our answer for question number 4. Now we can move on to question number 5. I will keep that definition of the power rule off to the side in case anybody wants to reference it if they're doing this along with me. So for question number 5, we have y is equal to x cubed minus x. Well, again, we're doing the power rule twice here. So we're going to do it once for the x cubed, and we're going to do it again for the x. So let's do it for the x cubed first. The derivative of y with respect to x will be equal to, bring down the 3, times x raised to the 3 minus 1, that's the first one, minus, that implies an x to the first, so bring down a 1, times x raised to the 1 minus 1, close parentheses, and we can simplify this down. We can say dy dx is equal to 3 times x squared minus 1 times x to the 0th power. We can say dy dx is equal to 3x squared minus 1. So anything to the 0th power is 1. And that is our answer for question number 5. Does this one read any better? Not really. I want to see if I can use this marker for a little bit longer. If I think it becomes any more faint than that, I'll just use a spare. So that was question 5. So let's move on to question number 6. So question number 6 is y is equal to 5x to the 4th minus 7x cubed. Well, it's getting a little faint, so I guess that means I have to write it a little bit bigger. We're going to use the power rule once here, and we're going to use the power rule twice the second time here. So let's use it on that first section. Y prime is equal to, pull out the 5, take the derivative of what's inside, so we have x to the 4th. Well, we know the derivative of x to the 4th is 4 times x raised to the 4 minus 1. Close parentheses. That's our first section. Minus, I'm going to erase these so you don't think it's 5 over 1 and 7 over 2. Minus, pull out the 7, then we will have the derivative of x cubed. Well, the derivative of x cubed, bring down the 3, is 3 times x raised to the 3 minus 1 power. Close parentheses. Now we can just simplify this down and say y prime is equal to 5 parentheses 4x cubed, close parentheses, minus 7 parentheses 3x squared, close parentheses. And now we can just multiply this out. So we can say that y prime is equal to 20x cubed minus 21x squared. You can plot an x squared. I wouldn't, because you could use power rule to find the second derivative. Here, if you plot an x squared, you've played yourself and you need to use product rule. The product rule is not bad, but it is a little bit lengthier. In case you're wondering what that would look like, it would look like this. Look like x squared 20x minus 21. But this is a product rule. So this is product. This is power. So that's a matter of preference. If you want to practice, you can always do that using product rule. But that's question number 6. So my mark is getting a little bit faint, so I'm going to go ahead and pull out a spare. So for question number 7, we have y is equal to x squared minus 25. Let's go ahead and write down our definition of the power rule over here. For a function y is equal to x raised to some number, the derivative of that function with respect to x will be equal to the number times x raised to the number minus 1. This is only one power rule because the derivative of a constant is 0. So the derivative of y with respect to x will just be equal to 2 times x raised to the 2 minus 1 power, which will be equal to 2x. So the first power, which is equal to 2x. That's the answer for question number 7. For question number 8, we have y is equal to e to the x cubed. This isn't a chain rule because it's not a composite function. So you cannot use chain rule. If you try to use chain rule, and this is a common mistake, if you try to use chain rule, you would get 3 e to the x squared, which already doesn't really work because the derivative of e to the x times e to the x. It is not 3 e to the x e to the 2x. That's not the answer to this one. You cannot use chain rule. This is a product rule. It looks like a chain rule, but it's a product rule. So what you want to do is you want to use properties of exponentials. I know that an exponent raised to an exponent is equal to the multiple of those exponents. So y is equal to e raised to the 3x. And then we can just go from here. So we know that the derivative of e to the x, e to the x, same concept. The first derivative of y with respect to x will be equal to 3 times e to the 3x. It looks weird. You think it would be something like this. You think it'd be, well, 3x times e to the 3x minus 1. This works for your regular numbers, but when you get to natural logs, and exponentials, and trigs, it doesn't really work out as well. Still the same principle, but this notation becomes a little bit weird once you get to those types of questions and equations. So that's question number 8. But that is the general definition of the power rule, which is why I'm still keeping it up there. For question number 9, we have y is equal to the natural log of x all raised to the 4th power. Now this looks like a power rule, but it's actually a chain rule. Now I know that sounds kind of hypocritical because I just said the last one wasn't a chain rule, but this one is, because essentially the natural log of x, all of that to the 4th power, is a completely different function than the natural log of x. Whereas e to the x raised to the 3rd power is e to the 3x, which is exactly the same as e to the 3x. So this one is actually a chain rule. So what you want to do here is you just want to go ahead and use the chain rule. I have an entire video on this, but I'm showing you this so you can see the overlap because they are closely related. The first derivative of y with respect to x be equal to bring down the 4. And then on the inside we have natural log of x raised to the 4 minus 1 power. That is almost identical to power rule. That's why I say that they're almost like siblings. They're very closely related. But here's the extra part. Times the derivative of what's inside. Derivative of natural log of x is 1 over x. That's the chain rule part. So it looks very, very similar to power rule, but it's not quite the same. So we can go ahead and simplify this off. dy dx is equal to 4 over x times the natural log of x, and all of that is cubed. And that is our answer for question number 9. Very closely related to the actual power rule. Very, very closely related. I only got one question left for you guys, so with that in mind, we're just going to go ahead and wrap this up with question number 10. Usually I don't go up to 10 questions, but since this is the literal shortcut to using the definition of the derivative, in case you're wondering, it's been a while for me, but the definition of the derivative should look something like the limit of delta h as h approaches 0 of f of x plus h minus f of x over delta h. This is more or less the definition of the derivative. If you guys want, I can make a full video on it and I can go back and brush up on it. It's been a while for me. I'm a little rusty with the definition of the derivative. But we don't need that because we have all the shortcuts. So we're just going to go ahead and erase that. We're not going to focus on that because we have the shortcuts. So for question number 10, we have y is equal to sine theta to the 5th. And everything is raised to the 5th. So you can write it like this. But that doesn't help you much for finding the derivative. So let's rewrite it as y is equal to sine theta, all of this raised to the 5th power. Because then we can just use another chain rule. So we can say the first derivative of y with respect to x is equal to 5 times sine of theta raised to the 5 minus 1 power. Again, almost identically modeling and mirroring that power rule, times the derivative of sine theta, which we know is cosine theta. There you go. So we can go ahead and rewrite this. The first derivative of y with respect to x is equal to 5 times cosine of theta times sine of theta, and all that is raised to the 4th power. I will use that notation because I think it looks a little bit neater. And that is our answer for question number 10. So that's actually all I have for you guys in this particular video. Once again, if I was going a little too fast, feel free to slow it down, and you can go to the comment section and I will have a link pinned with my PDF file with my notes, questions, and answers. So you can go ahead and refer to that, and then you can just follow along with me on that one. But that's all I have for you guys for this video. So if you have any ideas for future video topics, please let me know. And I hope you guys learned something, and I hope you guys have a nice day. Thanks for watching.